On this next example, we're going to look at comparing some volume. And so this first one says, make a quick guess. Which cylinder has the greatest volume? Explain your choice. And so when we're talking about volume, remember we're talking about the space that a shape takes up. Really, if we were going to fill these two containers with water, we're asking which one do you think holds more water? And at first glance, to be honest, I'll tell you my first glance guess would be this shorter, rounder one, this wider one. But let's see. Let's compare the two volumes and let's see what you think. So a quick guess for me is the first one. You can fill in whichever one you think there for your guess, so you should be filling that in for yourself. The volume formula, we know, volume equals pi r squared times h. So for each cylinder, we're going to find the volume. This first one, pi times r squared, that's 3 squared, times the height is 4. And then this second one, pi times the radius here is 2 squared, times the height of 9. And 3 squared is 9 times 4 is 36 pi units cubed. 2 squared is 2 times 2, which is 4, times 9 is 36. 36 pi is our exact answer. Exact is always in terms of pi units cubed. So we found the volume. Was our prediction correct? Well, my prediction was not. No, because they are both the same. Or they both have the same volume. So, two different cylinders that look very different, but they both take up the same amount of space. The space they take up just looks different. But we know by comparing their exact volumes that they have the exact same volume of 36 pi units cubed. As we flip open, we've got one more example where we're going to be talking about changing the radius. It says the company wants to double the volume of a can of graham cracker crumbs. The current container has a radius of 3 inches and a height of 8 inches. Mr. Smith suggests doubling the radius of the cylinder, or the cylindrical container. Will this double the volume? Why or why not? Well, let's first find the volume of the current container. So the current container, they're saying, has a radius of 3 and a height of 8. So volume equals pi r squared, which is 3 to the second power, times height, which is 8. 3 to the second power is 9. 9 times 8 is 72. So the exact volume here is 72 pi units squared. Or no, I'm sorry, inches squared. They tell us inches. Inches cubed. And then the new container, we're going to double the radius. So we're going to make 3 change to 6. Pi times 6 squared times the same height. They didn't say we were going to change the height. 6 squared, 6 times 6 is 36. 36 times 8 is 288 pi inches cubed. So it's asking us, will Mr. Smith's idea work? Well, 72, if we wanted to double that, times 2 would be 144, not 288. So will his idea work? No. Why or why not? Well, it's not going to work because the radius is squared. So doubling it, or doubling the radius, quadruples the volume. And I'll show you how I know that. I know that because the new volume is 288 pi. And if I divide that by the old volume of 72 pi, 288 pi divided by 72 pi, I get 4 times the amount. So if I took 72 times 4, I would get 288, which is quadruple or 4 times that amount. So all of this is equal to 4, and so I know that by doubling the radius, he actually quadrupled the volume of that cylindrical container.